How does the food you eat contribute to your health? Do supplements help prevent disease? For the past 25 years, the Linus Pauling Institute has served as a world-renowned research center at Oregon State University. Our mission is to promote optimal health through cutting-edge nutrition research and trusted public outreach. We use a synergistic strategy, connecting several scientific fields to bring a better understanding to dietary components and the role that they play in obtaining optimal health. We provide that information to the world, allowing people everywhere to live longer, better lives. Welcome to the Linus Pauling Institute's webinar series.
Hello, everybody, and welcome to the next edition of the Linus Pauling Institute's webinar series. This is all you wanted to know about vitamin E, but were afraid to ask. My name is Alexander Michaels, and I am the Communications Officer for the Linus Pauling Institute. It is a great pleasure to welcome everybody to the Linus Pauling Institute's next edition of our seminar series. This is our third webcast of the year, and this one's on everyone's favorite fat-soluble antioxidant, vitamin E. For that, we're going to call on the expertise of our own resident expert on the topic, Dr. Maret Traber. But before we do that, I'm going to call on Dr. Emily Ho, the director of the Linus Pauling Institute, to come on the virtual stage for a welcome. Emily?
Hi, everyone. Welcome to the Linus Pauling Institute's webinar series. I hope everyone's having a good summer so far. Here in Oregon, the sun has finally come out again, so we're excited about that. And we're even more excited today. We're going to talk about vitamin E. And I've been wanting to have our speaker today, Dr. Maret Traber, for quite some time, because I think vitamin E is one of those misunderstood molecules. There's been a lot of confusion around vitamin E, its role in health, potential adverse effects, and this has driven a lot of people away from taking vitamin E supplements or even foods that are high in vitamin E, and it is one of our essential nutrients. So today, Dr. Traber is going to set the record straight and get right to the facts. And she's the perfect person to do this. She is the goddess of vitamin E. She even has a plaque and a big banner that proves this fact. And I can go on, but I'm going to stop here for now and let Alex do the rest of your introductions and get to the seminar.
Thank you, Emily. This webinar is going to go pretty much like all the rest of our webinars. Dr. Traber is going to give her presentation, which will last approximately 30 minutes. This is a 1-hour webinar session, so the rest of the time will be dedicated towards Q&A. And I'll go over the Q&A session rules in just a moment. Actually, I'll do that after Maret's presentation. But the goal is to wrap up this webinar at about noon Pacific time. So I think we just need to get moving. But if any time you do have a question, I'll go over more detail later, but there's a Q&A button down below on the screen. If you just type your question in there, we'll try to get to it during the webinar today. Okay, I think we're ready to get on to the presentation. Maret, would you like to turn your camera on? Oh, I got to get you on the screen. Okay. So, as I said, our speaker today is Dr. Maret Traber. Dr. Traber has been part of the Linus Pauling Institute since 1998. She was one of the first investigators to come to the Institute after its move to Oregon State University. Dr. Traber has a background in nutrition. She received her bachelor's degree and PhD in nutrition from the University of California, Berkeley. At that time, she was deeply immersed in cholesterol, lipoprotein research, and cholesterol absorption, turnover, and transport. After moving out east for a while, I think she was at Rutgers and NYU School of Medicine for a bit. You kind of started changing your focus and looking at vitamin E, the prominent antioxidant in those cholesterol molecules. And the rest was history. So after establishing her research program in vitamin E, she came back to UC Berkeley and worked a little bit at UC Davis before coming to the Linus Pauling Institute. And right about that time when she was transitioning between UC Davis and here, she was serving as a member of the panel of antioxidants and related nutrients for the Food and Nutrition Board. This is the board that helps bring the scientific perspective for things related to our dietary requirements. So the RDAs that we all know and love. These are kind of evaluating that evidence and trying to set recommendations for your health. And so she was involved in setting the RDA for vitamin E in 2000. She's been working here at the Institute ever since. I believe that she has approximately 200 papers on vitamin E, really close to 200 papers on vitamin E. And one of her papers, Vitamin E Function and Metabolism, has been cited over 2,000 times in the literature. She's received many grants for her work on vitamin E and received and been served on a number of boards and committees for nutrition. Recent awards, I should mention, she became an American Society of Nutrition Fellow in 2021, and she also received the Medical Research Foundation of Oregon's Discovery Award last year. I also should mention that Maret is the Ava Helen Pauling Professor at the Linus Pauling Institute. Her most recent work has been focusing on vitamin E requirements in early life and how vitamin E shapes embryonic development. But I'll let her get to that if she's ready to start her presentation. Without further ado, the floor is yours.
Oh, Alex, thank you so much. That is really nice. I love talking about vitamin E, and you said 30 minutes, not 30 days, right? Okay, 30 minutes it is. I wanted to talk about everything you wanted to know about vitamin E and really focus on why we need vitamin E and what does it do in our bodies, and actually how it protects us from chronic diseases, things like Alzheimer's disease. So to get a move on, my little computer is dinging at me because I was supposed to press the button that goes that way. So everything about vitamin E is what I wanted to talk about, and we get to celebrate vitamin E's birthday. And you've heard everybody say it's a fat-soluble antioxidant. Well, what is that? And you've heard all kinds of information about different forms of vitamin E. Plants make 8 of them. Do we need them all? What about natural versus synthetic vitamin E? And do humans need vitamin E? Absolutely. Otherwise, I wouldn't be giving this lecture. But what tissues is it important for? And what about the brain? And finally, how much is enough? One of the questions that was posed to me is 20,000 IUs too much? The quick answer is yes, but how much do you really need? So happy birthday, vitamin E. It is the 100th birthday of vitamin E. Evans and Bishop published in 1922 on the existence of a hitherto unrecognized dietary factor. They published that in Science magazine. This is a picture of Evans. Catherine Bishop's picture never seems to show up, but we'll put that aside for the moment. They probably didn't have enough money for research. Just like today, we don't have enough money for research. And what they were doing was feeding rats rancid fat, and the rats didn't have babies. And so they worked on that for a while and figured out that the diet was missing something. And what it was missing was what they called alpha tocopherol. And the name tokos comes from the Greek and means offspring. So the idea was that this is a vitamin that's important for pregnancy. And they first described it in 1922. It took them 14 years to figure out that they could isolate alpha tocopherol from wheat germ oil and identify the molecule. these days you ought to publish 14 articles in a year, not take 14 years to publish one. But back to pregnancy, what about the embryo? We know the moms need vitamin E because all the rat studies and the mouse studies showed that, but it was not clear what the embryo needs. So we used the premier vertebrate model of embryology to study the embryo, because clearly you can't study embryos in pregnant women, and you can't study even with rats and mice. It's a tricky thing to study embryos, and people had been doing it for 50 years already, and it was not helping a lot. The zebrafish is interesting because it goes from a fertilized egg to a swimming fish in 5 days. And we could feed the adults the vitamin E deficient diet and get vitamin E deficient embryos. And what we found was that vitamin E deficiency causes early embryonic death. 80% of the animals were either dead or deformed in those 5 days. We found not only was it critical during embryonic development, but it was especially critical for brain and spine formation. Think neural tube defects. We're going to come back to that whole issue of how does vitamin E have anything to do with folic acid and maybe neural tube defects? What we do know is in humans, vitamin E is critical for the embryo at a time prior to when a woman knows she's pregnant, and that is prior to implantation. So this is a very critical period for the embryo to form. Now, why is that? What is going on? And, you know, it's been known for forever that it's an antioxidant. What is this antioxidant free radical thing? So antioxidants balance oxidants, and oxidants damage everything: DNA, proteins, fats, carbohydrates. But that's not terribly informative. If we take a look at the origins of free radicals, gamma rays from outer space, UV light, radiation, tobacco smoke, ozone in the air, all kinds of environmental damages are sources of free radicals. Not only that, but your mitochondria, the energy pump in the cell, electron transport chain. That means they've got free radicals happening and the mitochondria tries to control them. Phagocytic cells, those are white cells. Those are the guys that we're trying to get to kill bacteria, to kill viruses, and they do it with free radicals. And of course, those radicals damage everything. So what is this free radical thing? It's an atom that has an unpaired electron, like right here. And this unpaired electron, the electron likes a friend. And so it reacts very rapidly with other molecules. And one of the most dangerous ones, hydroxyl radical, but probably one of the most famous ones that you see or you breathe every day is oxygen. It has 2 unpaired electrons. And when you reduce oxygen to hydrogen peroxide, and then you break this bond, you make that hydroxyl radical. And the hydroxyl radical forms because you have some free metal like iron, and that can really damage DNA. Now, despite all that scary stuff, I think the most dangerous reaction is lipid peroxidation. And that's because it's a chain reaction. I don't think any of us have smelled rancid fat, but because we have all of these antioxidants in our fats now, because polyunsaturated fatty acids are highly susceptible to lipid peroxidation. And once it starts, it's a chain reaction. And polyunsaturated fats are in membranes. Every cell in your body depends on having its polyunsaturated fats protected. Now, what do I mean by chain reaction? So this initiating event, like a gamma ray from outer space, knocks off a bond and creates this free radical, which reacts with oxygen. Remember, it's got 2 unpaired electrons, and those unpaired electrons react, and we make a peroxyl radical in the membrane, and it goes and steals the hydrogen from polyunsaturated fat, becomes a lipid hydroperoxide. But the exciting part is it generates another free radical. So we're generating radicals by this process. So maybe if you don't think gamma rays from outer space happen a lot, electron transport generates these also. And this lipid hydroperoxide is like the peroxide where you can generate another radical in the presence of metals. Therefore, the body makes enzymes that get rid of this. So what does vitamin E do? It's our hero. It stops the chain reaction before it can attack the membrane. So the vitamin E is sitting in the membrane like a little sentry, and it is patrolling. And as soon as it encounters this radical, it reacts with that radical 1,000 times faster than the radical can get to the membrane lipids or the polyunsaturated fats. We generate a vitamin E radical, and that lipid hydroperoxide is formed. So the enzymes still are needed to protect you from lipid hydroperoxide. But now we have a long-lived radical. What do we do with that? Well, this is a cycle that Lester Packer liked to talk about a lot. And he liked it because the vitamin E cycle interacted with vitamin C. The vitamin E got reduced. The vitamin C got turned into a radical. And then vitamin C reacted with glutathione, and glutathione could get oxidized. And there are enzymes that protect you from oxidized glutathione, and they use NADP or NADH or NADPH. Essentially, they're using the energy production of the body to regenerate vitamin E. Well, all that's great. Doesn't explain, though, why did the embryos in our study die? Why were they so messed up? So we've been looking at this using metabolomics techniques. Look at not only fat soluble and fats, but also water soluble compounds. And this is a very complicated slide. If we had more time, I would tell you all about it. But basically, what's happening is membrane phospholipids have choline. 97% of the body's choline is locked up in membranes. Choline is also needed to be a 1-carbon donor. So 1 carbon's betaine donates to methionine, S-adenosyl methionine, homocysteine is reduced this way. So these are very important reactions. But perhaps what's more important is this pathway intersect with folic acid. And folic acid, we know, is critical to prevent neural tube defects. So I would suggest to you that one of the reasons the embryos got into such big trouble when they didn't have vitamin E is all things went awry. We generated damage to membranes. We used up glutathione, and this pathway to generate the critical amino acid cysteine to get to glutathione was also in trouble. And altogether, cells are dying because they're unable to control those free radical reactions. Now, that's a good story. It says vitamin E is really important as an antioxidant, not just for lipids, but for maintaining cell metabolism. Now, vitamin E is really quite ancient. Plants started making vitamin E because they were releasing oxygen into the environment and they needed to protect themselves. They make 8 different forms of vitamin E. Do humans need them all? And so a little bit of chemistry, don't get scared and run away. This is the hydroxyl group on the vitamin E that donates the hydrogen. You can see these other forms of tocopherols also have this hydroxyl group. So they're all antioxidants. The important thing here is the phytyl tail. That holds the vitamin E in the membrane so it can be a little sentry. And this position, the 2 position, is exactly how the vitamin E is held in the membrane in the correct form, the right-handed form. Now, I said there are 8 different forms plants make. The other forms are tocotrienols. They have the same head groups, but what's different is they have an unsaturated tail, which makes it more fluid. That means it can run around the membrane faster. But we already know that alpha tocopherol as an antioxidant in the membrane is reacting really fast. So faster may not be necessary. And it was way back, 1937, when alpha and beta and gamma tocopherols were first isolated, discovered, and the confusion, alpha tocopherol being the most effective form to prevent those vitamin E deficiency symptoms, it was very confusing. Why is that? What's going on here? These are all antioxidants. They're not that different from each other. But alpha tocopherol seemed to work better. And it's taken a long time. When I started working on this vitamin E problem back in the last millennium, we were looking at alpha tocopherol having the highest biologic activity, but gamma tocopherol was 10 times higher in the diet, especially here in the US where we were eating a lot of soybean oil. So why did the body contain more alpha tocopherol when you're eating more gamma? And it was clear you couldn't convert. You cannot convert gamma to alpha. And if you look at these 2 molecules, they don't look a lot different. There's just a little bump here and a bigger bump there, but that's about it. So we worked with some folks from Canada. Jeff Atkinson made the deuterated gamma tocopherol, deuterated alpha tocopherol. And what we saw is if you fed them both to people for breakfast, they both got absorbed. They both appeared in the plasma about 12 hours, 9 to 12 hours was the peak. But then gamma disappeared so much faster. In fact, we measured what is the half-life? How long does it take to get rid of half of what you got in the plasma? The difference here is tenfold. So you can tell it's a whole huge difference. It takes 48 hours for alpha tocopherol for half to disappear. But for gamma tocopherol, it disappears in 15 hours. Now, other people studying tocotrienols reported that alpha tocotrienol disappears in 4 hours. So alpha tocopherol lasts 10 times longer than alpha tocotrienol. So what is going on? How does that happen? I've been studying all kinds of factors that might be important. Absorption, we'll talk about chylomicrons, lipoprotein transport, tissue uptake, what goes on in the liver. I don't have time to talk about catabolism, but if there are questions, I'm happy to address those. So Rich Bruno made this slide for me. It really nicely shows exactly what's going on. We have the diet that can have up to 8 different forms of vitamin E that you eat that gets into your stomach. The small intestine makes a specialized lipoprotein. Lipo means fat, protein, it's got protein too. And these are like semi-trucks. They move nearly 100% of the fat you eat through the body and delivers it to the liver. Look what happens though. You have alpha tocopherol in the liver, but all different forms of vitamin E that are coming in. How does that happen? Well, it turns out that there is a special protein, alpha tocopherol transfer protein. We're going to call it TTP. And TTP grabs alpha tocopherol, moves it to the cell membrane, and secretes it so that very low density lipoprotein, a big triglyceride moving lipoprotein, can carry alpha tocopherol into the plasma. In the plasma, VLDL is converted to LDL and HDL. This is the good and the bad cholesterol, or the bad and the good cholesterol, depending which way you want to say it. But alpha tocopherol is carried in those lipoproteins and delivered to tissues. So when you eat your dietary vitamin E, what the tissues get is alpha tocopherol. It can also carry it back to the liver, where TTP picks it up. And so you have this circulation, which is how alpha tocopherol is maintained in the plasma. The other forms of vitamin E, like gamma tocopherol, the tocotrienols, are actively metabolized and excreted. Now, how does TTP work? Well, some of you may be interested in natural versus synthetic vitamin E. Natural vitamin E is what we've been talking about, RRR, and its critical importance right here, that it's right-handed. Over here, SRR is an example of half of the forms of vitamin E in synthetic vitamin E. And it turns out there are 3 places in vitamin E that could be right or left. And here you have the left form. Unfortunately, our tocopherol transfer protein isn't both right and left. It is only right. Therefore, TTP grabs alpha tocopherol that has the 2 position. So natural, 100% is used. Synthetic, only 50% is the 2R form. The other part that's important is we've been talking about gamma tocopherol. This methyl group is the one that's in alpha tocopherol, missing in gamma tocopherol. And because it's missing, it doesn't stay in this pocket part of the mitten very well, or the protein. And so this molecule is not retained. And because this one doesn't fit very well into the mitten, it's not retained either. So both gamma tocopherol and SRR have a half-life of about 15 hours. Remember, the natural form had a half-life of 48 hours. So do humans need vitamin E? Well, Yes. And the reason we know that is there are people who have a genetic defect in TTP. They are unable to recognize the different forms of vitamin E. They're unable to retain the alpha tocopherol, and they become vitamin E deficient. And their deficiency symptoms include a peripheral neuropathy. That means they can't feel their hands and feet. The nerves die from the hands and feet. They die up the spinal cord, causes ataxia and inability to walk. This goes to the brain. By that time, I hesitate to tell you that this is fatal. They also have weakness in their muscles, weakness in their heart muscles. Children are usually the ones that are recognized to have this, and they have died from it. Now, pediatricians are really good at recognizing the symptoms. And if you've gotten vitamin E from childhood in large amounts, if you have this disorder, you can actually be protected from all of those symptoms. What's also interesting about TTP is for a long time, we thought the only tissue that expressed it was the tocopherol transfer protein. My friend Hiroyuki Arai was the first to isolate TTP from rat liver. And he has this very nice review article that shows that TTP is expressed in the brain. I don't know if you can see that, it says brain right there. Also in the eyes, as well as in the placenta. And what's important about this is that specialized cells grab the vitamin E from the blood, transfer it to cells that need it, like Purkinje cells, which are needed to prevent ataxia. In the eye, it protects the retina. And in the placenta, it's helping transfer vitamin E into the fetal circulation. Now, those tissues, because they express vitamin E, they probably require more vitamin E. And there have been some clinical studies that give us some hints that supplements may have benefits in some diseases. For example, fatty liver disease, NAFLD, NASH. These are diseases both in adults and children where so much fat accumulates in the liver that the liver can't function properly. Eventually, it can lead to liver cancer. So very serious. There are no pharmacologic agents that work yet, but surprisingly, large vitamin E supplements are beneficial. It's still not clear exactly how they work in this disease, and this is an ongoing area of research. In addition, eyes. You may have seen in your grocery store the Arids formulation. This has both vitamin E and zinc, as well as lutein and zeaxanthin, which are important for the eyes. The data so far shows that this Arids formulation slows the progression of macular degeneration, a very serious eye disease in the elderly. And it does not stop it, but it does slow it. We can say that with confidence. And finally, Alzheimer's disease. Early on, there were reports that vitamin E supplements were beneficial, and then there was confusion and no, it doesn't work. More recently, there have been reports that yes, it does work. So the latest from 2017, the meta-analysis is leaning towards vitamin E may be helpful to slow Alzheimer's disease. But again, this is an area of research. And I wanted to tell you about a study I did in collaboration with my colleague, Dr. Gene Bowman, up at the Oregon Health Sciences Center. He was interested to know what dietary patterns will prevent dementia. And I would phrase it more simply, what should you eat to be smarter? You may really like chocolate cake, but maybe fruits and vegetables are good for you, or salmon, Big Mac, I don't know. So what Dr. Bowman measured were 30 plasma biomarkers of diet. He was interested in the elderly. So this is a brain aging study cohort, and the average age was 87 years old. So definitely an aging cohort who had lived to be that old. And so what did they eat? And it's hard for most people to remember what they ate yesterday. So the elderly, it may be even more difficult. He asked, if we measure biomarkers in the blood, can we relate those to cognitive function and brain size? And the answer is yes. Two patterns of blood metabolites that were more favorable with cognition and MRI measures were vitamin B, C and D, and of course, vitamin E. And I think what struck me about this data is we've just talked about what happened in the embryo, and that if you didn't have vitamin E, that impacted B also. And so here it is that they're working together, maybe in the plasma. Also, N3 fatty acids, fish oil was really important. So there's your answer. Eat lots of fruits and vegetables, eat fish. And trans fat, less favorable cognitive function, less total cerebral brain volume. Trans fats, they've tried to get out of your diets by encouraging manufacturers to not put it in the first place. But there is saturated fat also has this little bit of a problem. So now you know fruits and vegetables. And now all you need to know is how much. How much vitamin E is enough? And that RDA panel that I was on, we came up with a number, 15 milligrams a day. Couldn't find any evidence for higher levels for pregnancy, but lactation, you should try and take more vitamin E so that the breast milk has vitamin E. With regard to children, we treated them like small adults, and the numbers go down proportion to body size. Well, 15 milligrams. How does that equate to 400 IU? This is very confusing. So let's see if we can break it down for you. 96% of women do not even eat 12 milligrams of alpha tocopherol a day. And that's probably because they avoid eating fat. 90% of men, no, they don't eat it either. Where is it? How come we can't get it in our diets? You could get it from fortified breakfast cereal, but this is not just regular breakfast cereal. This is something like Total, where it's a vitamin pill in the bowl. We also have nuts and seeds. So nuts are a great source of vitamin E. You'll notice that these vegetable oils, 1 tablespoon, if you're eating soybean, not so much alpha tocopherol. Sunflower, much more alpha tocopherol, but it's really hard to cook with. So a compromise might be canola, where it's a kind of intermediate level of alpha tocopherol. All kinds of green leafy vegetables. I absolutely endorse green leafy vegetables as a source. You eat 2 cups of spinach a day, like Popeye the Sailor. Well, maybe that's a little over the top. Emily, if you're listening, broccoli also is got 2 milligrams of alpha tocopherol. So the idea is if you eat a lot of different fruits and vegetables, you have a good chance here. But I'm not recommending potato chips or French fries. It's just that manufacturers spray on the vitamin E as a natural antioxidant. So 15 milligrams doesn't seem like a lot compared to the 400 IU pill, but on the other hand, 15 milligrams seems like a lot when you try and talk about cups of spinach to eat. This is an interesting story. It is what happened to the participants in the ATBC trial. This was the alpha tocopherol beta carotene cancer prevention trial. And what was exciting about this is beta carotene caused cancer. So that was somewhat of a shock to everybody when the study was done 30 years ago. In the 30-year follow-up, 23,000 people have died. These were Finnish smokers largely. And what this study is presenting you was what the serum vitamin E was when the study started at baseline. And they asked the question, if you had a great diet versus having a diet that was low in vitamin E, such that your plasma was low, what happened? And it turns out that even a little bit of an increase is enough to cause a decrease in mortality. And the overall study showed there was significantly decreased mortality from everything: cardiovascular disease, heart disease, stroke, cancer, respiratory disease, other causes. What the message is here: eat a good diet because it's worth it. You can actually improve your chances of getting serious cardiovascular or other chronic diseases by eating a better diet. Every nutritionist you talk to will agree with that statement. So what about those supplements? I told you all kinds of diseases, and we've talked about how much vitamin E to get what kind of plasma concentration. What you can see here with this little blob that looks like a vitamin E pill is how much you had to take. If you took 400 IU, what did your plasma concentration look like? And what you can see from this picture is more vitamin E does not get you more in the plasma. The tocopherol transfer protein is regulating it. And up to about 400 IU, you can get an increase. After that, it's flat. So don't waste your money. 400 IU is plenty. This level is way higher than those Finnish smokers at baseline. So maybe that 400 IU pill once a week is good enough. And I can tell you, we did our homework and figured out what are the numbers to convert IUs into milligrams. And now the FDA has agreed with this. And if you are getting natural, that pill has 268 milligrams. If it's synthetic, it's 180 milligrams in the pill. You can see it doesn't matter because you end up with the same plasma concentration. So time flies when you're having fun. At least I was having fun telling you about my vitamin E stories. We talked about vitamin E's discovery, that it's an antioxidant, that those oxidants are around us both inside and outside our bodies. Although plants make all kinds of different forms of vitamin E molecules with antioxidant activity, you don't need them all. What you need is alpha tocopherol. It's really important for the liver, the brain, the eyes, and during pregnancy. And we focused on the brain mostly because everybody wants to retain their cognitive function. But it shows a very real example that what you eat is really going to protect your brain, and it's good for you. And how much is enough? I think 15 milligrams really is enough, the amount you can get in your multivitamin pill. But if you have some of these more serious conditions and want to slow down the progression, there is evidence that vitamin E is beneficial in some of those conditions I discussed. So with that, I'd like to thank the Linus Pauling Institute and Oregon State University for well, it's been a wonderful opportunity to work in this beautiful building in these great labs and to be able to study vitamin E. And thank you so much. And I'll stop there and turn the screen back over to you, Alex.
I'm actually going to pop up. Thank you, Dr. Traber. That was an amazing talk.
Thank you.
Lots to think about. But before we get to the Q&A, I just want to remind attendees, first of all, I want to thank all the attendees for coming. There are about 200 of you, and we had about another 600 to 800 register. Just a reminder, so as registrants, you will get first notice in terms of this recording. You'll also have access to Dr. Traber's slides as well. There are a few questions in the chat about that. I also want to remind you, if you haven't seen our previous webinar series from this year, we had one on vitamin C, one on cruciferous vegetables and cancer as well. Those can all be found on our YouTube website and our website as well. So if you want to visit our website, you'll get there as well. We're going to be taking a little bit of a break from webinars this coming summer. So our next series will start again in the fall. But in the meantime, definitely encourage you to visit our website for additional resources, especially the Micronutrient Information Center. If you don't get our newsletter, please subscribe to it. We often have accompanied articles that, for example, answer some of the questions that we don't get to during the online webinar time. So please check that out. As Dr. Traber mentioned, visit our website, lpi@oregonstate.edu. If you have additional questions, visit our resources as well. And if you enjoy these webinars, please consider donating as well. So with that, let's get to some questions. I'll bring Alex back on.
Okay, let me do a little quick rearranging here.
We'll go for the easy questions first.
Yeah, that was a great presentation, Maret. I think you've answered some of the questions that came up about how much to take. There's a lot of questions about dose. I think some people want to know, because there's people out there who suggest taking high supplemental doses, and what their rationale is, and what cautions to add to that.
I think it's a really important question. Probably around 2005, 2006, there was huge enthusiasm for vitamin E supplements to prevent heart disease. Mm-hmm. And there were a lot of trials. And then there were meta-analyses, and those meta-analyses said, vitamin E is dangerous, it'll kill you. And I was like, what? This is like the safest vitamin I know. However, those have persisted. And one of the reasons there's not a lot of enthusiasm for giving vitamin E supplements if you have fatty liver disease is because the physicians are saying, oh, but it's dangerous. Those levels, we found they were causing problems. And so I actually looked very closely at what are the problems? Could you put a bunch of those studies together and say, this is the mechanism of the problem? And the answer is no. Mm-hmm. Every study seemed to have some other adverse effect. And when I looked more closely, it all had to do with vitamin K. Mm. Whoa, how does that happen? It's not clear, the mechanism of how vitamin E and K interact. And honestly, I didn't actually believe that could be true until I actually did the studies in my own lab. but vitamin E somehow decreases vitamin K levels. And vitamin K is important to protect your artery wall, to keep your blood pressure down. It's important as a prostate and bladder cancer inhibitor. The protein involved is involved in activating vitamin K. Vitamin K actually regulates sterol synthesis. If you have destroyed the protein that activates vitamin K, this is UBI-AD1 if you want to look it up, but you end up with your eyes full of cholesterol. It's weird stuff. And I think that's one of the reasons it's been so hard to pin down what are the adverse effects of vitamin E, because people eat different levels of vitamin K and are differently protected. And I think the most obvious example was the SELECT trial. This was huge numbers of men, I think 30,000 men who were taking vitamin E supplements, and they reported back, oh, increased prostate cancer by vitamin E. And everybody was scratching their heads and saying, how does vitamin E cause prostate cancer? Well, the answer is, it was driving down vitamin K. And I think those men were not adequately supplemented with vitamin K. So the amount matters. If you're concerned and you don't eat a lot of green leafy vegetables, the amount in a multivitamin, I think, is plenty good. All of these pathways interact. And so all kinds of other things are protecting you also. So 15 milligrams really is enough.
So to reiterate some of your point right there, is the green leafy vegetables are also a good source of vitamin K. So you're getting E and K at the same time.
Yeah.
To keep that in balance.
Kale is great.
Yeah. So actually, since you mentioned cancer and heart disease, I'm going to mention the U.S. Preventative Task Force just released a statement about vitamins and cancer and heart disease, and they specifically called out vitamin E because of risk of hemorrhagic stroke. Do you have any comment on that one?
Vitamin K.
Okay, that makes sense. Yeah,
and it turns out there was the Women's Health Study. That was a 10-year study, 600 IUs of vitamin E every other day for 10 years. And what they found? Decreased thromboembolism. So decreased blood clots in your veins. And what they said in their discussion was that vitamin E was safer than warfarin, and it prevented blood clotting. So the hemorrhagic stroke is coming from, you need all of these things in the proper amounts. Right. I think if you don't have enough vitamin K, you're in trouble. Right. You need vitamin C too, which you get from all those fruits and vegetables.
I was going to bring up that one. Okay. You beat me to it. So, I mean, vitamin K and vitamin E, I don't want to spend too much time on this, so we have other questions to get to. They have similar, some similarities in chemical structure, right?
Yeah, the tails are the same. And so you eat spinach that has phylloquinone. The UBI-AD1 enzyme clips off the tail, puts on an unsaturated tail that looks like tocotrienols. Yeah, I think this is the reason the body gets rid of tocotrienols. They don't want to mess up menaquinone 4. So the body is actually making vitamin K2, and it's really important in the brain. We don't know exactly why, but vitamin K is really important for regulating calcium. So,
yeah.
Hey, it's another webinar. Invite me back.
Right. Let's see. So one question that we did get when you were talking about vitamin E in the brain was, how does vitamin E get across the blood-brain barrier?
Good question. We don't actually know. There are small capillaries. the exciting part of tocopherol transfer protein being in glial cells is they have access to those capillaries and could pick up vitamin E from the circulation. Likely HDL is a carrier, but this is all speculation on my part. I would say if you put an animal on a vitamin E deficient diet, all the tissues lose vitamin E except the brain. The brain can retain vitamin E a long time because of that tocopherol transfer protein.
So there's a lot of questions about sources as well. I mean, we just covered green leafy vegetables, but a lot of people like to get their vitamin E from nut seeds. And there was a question about wheat germ oil, for example. Do you have any comments about like oils and E, and also, just processing, cooking? Do we have to worry about that when it comes to vitamin E stability?
So what I would say is what we do in the lab is we take a piece of tissue and cook it in an alkaline solution with a huge whopping amount of vitamin C as an antioxidant to protect it, and we can hang on to 100% of it. So I don't think cooking actually hurts vitamin E. It is in the food in a matrix. It's protected. Once we've extracted it and have it in a solvent, all bets are off. Then you can destroy it with light and oxygen and everything else. But don't worry about cooking.
So oils, though, if you're storing an oil in your pantry, is there a risk for a certain amount of?
So there's pantries and there's pantries. In the United States, you buy your oil, it's in a clear bottle, you take it home, it's got plenty of BHT, BHA, other stuff in it. I don't know, all of the preservatives. But people, if you leave it on your shelf for 3 months, a year, it's pretty much okay. However, in less developed countries, oil is extremely expensive. And so people go to the grocery store. No, they go to the little shop on the street where they have a big bag of oil. And they transfer the oil from their big bag into your little plastic sack. So you get your half a cup to cook with this week. And in the sun, in the heat, you take it and you fry with it and you save it because it's expensive. And so there's real concern about how stable are these vegetable oils? Have you destroyed all the vitamin E? And the answer is probably yes. And to give you maybe some evidence of that is in Bangladesh. What they found is that women who have low, and this is less than 10 micromolar, so in the US we're all at 20 and above, 10 micromolar vitamin E in the plasma, they have doubled the rate of miscarriage. I think due to vitamin E. Keith West, who's done the studies, is not quite willing to say vitamin E will cure it, but he doesn't disagree with me in private.
But either way, if you've got a source of vitamin E and you decide to keep it in the fridge, for example, that's going to hold on to it longer, no matter what, or a freezer.
Cold and wet. It's really not necessary. Okay, but I would say most of the forms of vitamin E you buy as supplements are as esters, tocopherol acetate, and that is solid as a rock. It stays for decades. Right. I wouldn't worry about a vitamin E pill. If it says tocopherol, OL, not YL acetate, then you've got troubles. And then really pay attention to what the manufacturer says is how long you can leave it on your shelf. You should be using it, but.
So I'm going to ask two related questions. The first one's about vitamin E status and how to assess it. And I know you have some comments on that. And then I think related to that, some people want to know, are there certain situations where you may want to have more vitamin E, like if you're a smoker, if you're older, other chronic, not necessarily diseases, but just lifestyle choices or other conditions that you might have.
I think if you have a family history of oxidative stress, so diabetes, heart disease, Alzheimer's, all of those, I would be very serious about making sure you got the multivitamin level of vitamin E. If you feel like my family has Alzheimer, maybe I would be happier with a vitamin E pill. Yeah, go ahead. Just make sure you get your green leafy vegetables. I showed you how vitamin E recirculates in the plasma. In fact, the vitamin E turns over. The entire amount of vitamin E in the plasma is replaced daily. Oh, wow. So we know that the plasma is in quick equilibrium with the diet. What we don't know is tissues. And I've done some studies in children who had undergone burn and smoke injury. And there we could actually see that they had lower levels of vitamin E in their adipose tissue. And that is a storage spot for vitamin E. So it's very possible, if you really want to know your vitamin E, you have to measure it in the adipose, and nobody wants to do that. Blood levels don't tell you a lot unless you're low. And then they tell you, boy, are you in trouble. So for most people, it's really eat a good diet, you're fine.
What about, we've done some work with this with the hazelnut study that we worked on. The urinary vitamin E. And is that a good marker, or metabolites maybe?
I love the vitamin E metabolite. You're going to have to invite me back for a whole nother seminar on vitamin E
just
metabolites.
Talk about hazelnuts.
Yeah, well, hazelnuts is great because what we did is we had people eat hazelnuts for about 3 months, if I remember correctly, and we could hardly see a change in their plasma. But this vitamin E metabolite that's in the urine, that was significantly increased. So it said, yes, we can detect a change due to dietary changes. I just noticed that we're over noon. Does that matter? Are you guys going to go?
I was just going to say, yeah, I think we're going to have to call it here. Unfortunately, a lot of questions did come in towards the end of your presentation, and I want to tell everybody that we have a copy of your question, and we're going to provide supplemental information from Dr. Traber after the webinar is over. Obviously, we have to give her time. So this is one of the plugs for the research newsletter, because we often give extra information in our research newsletter for the questions that you submit. And of course, you can always email us at lpi@oregonstate.edu. So I'd like to thank you, Maret, for coming on and giving us a primer on vitamin E. We certainly would love to have you back to discuss more of those interesting topics we just brought up.
Well, I had so much fun, and I could talk for days, weeks, months, years about vitamin E.
Yeah, well, you have. Okay, well, as we close out, I'm going to bring Emily on one more time to wrap us up.
Thank you all for being here. Big thank you to Dr. Traber for lending us her brain for the last hour, and lots of great information there. And again, reminder, you should be, if you want to revisit the webinar, we'll be sending you those links as well. We're working on our next webinar, but it won't be until the fall, so look for announcements later this summer. We're also going to have a special digital edition of our newsletter coming out this summer as well, so make sure you take a look for that. As always, if you have any comments, questions, please let us know at lpi@oregonstate.edu. And again, please be sure to visit our website or our social media pages for additional information. Thanks for spending the time with us today. Have a great summer, stay healthy, and stay well.
Bye.